All right, so on to question number 6. What are the electron and molecular geometries, respectively, for the carbonate ion CO3 2-? So before we get into the geometries, electron and molecular geometries for this ion, we need to first draw out its Lewis structure. So we need to first determine the total valence electrons for this ion. So in the case of a carbon atom, carbon has 4 valence electrons, and oxygen atoms contain 6, and we have 3 oxygen atoms, so we multiply this by 3. And notice that the ion has an overall 2- charge, so I'm going to add an additional 2 electrons to our total number. And if we were to add this all up, we would get 24 valence electrons. Okay, so first I would draw out my carbon as my central atom, and then see what happens if I just have single bonded oxygens all around. And I'll draw out all of my lone pairs. And at this part, I like to count out how many electrons I've drawn so far. So in the case of all of the bonds, each bond contains 2 bonding electrons, so we have 6. And then each oxygen atom has 6 electrons. So we have 24 drawn so far, but if we look at our carbon atom, it doesn't have a full octet. So I need to make one of these oxygens double bonded and erase one of the lone pairs. And now if we count it out, I still have 24 electrons, except this time my carbon is has a full octet. So now I have my Lewis structure, and these 2 oxygens here have a negative charge. So we know that this is correct because that's what we're looking for. So I can also draw the resonance structures just by showing how each oxygen can have a double bond. Okay, so these are all the different resonance structures that you could have for this ion. Okay, so now we need to find out the electron and molecular geometries for this ion. So let's just look at one of the structures. And we're focused on our central atom, which is the carbon. So carbon has 0 lone pairs. And it also has 3 bonded atoms. So all those 3 oxygens. So at this point, we would use the Vesper table to help us try to find out the type of geometry this ion has. So this is a Vesper table, and it's really helpful because when you match up the type of molecular shape you have, it'll tell you the type of hybridization and the different bond angles that you would find in your molecule. So in our case, we have 3 bonded atoms and 0 lone pairs. So this means our molecular shape and our electron geometry, they're both trigonal planar. And the carbon is sp2 hybridized. And the bond angles are 120 degrees. Okay, so let's see what the junior tutor said. From the Lewis structure of the carbonate ion, it can be seen that the central carbon atom does not have any lone pairs. For any molecule where the central atom does not have any lone pairs, the electron geometry will be the same as the molecular geometry. So then they drew out all the Lewis structures. Using the AXE method of determining molecular geometries, for the carbonate ion, this is AX3, which it corresponds to a trigonal planar molecular geometry. Therefore, the electron and molecular geometry for the carbonate ion is trigonal planar. So this solution is correct.